For the question 2, we will also have a piecewise function that is from the boundary t less than 2, less than -2, the ft will be 0, and from the boundary -2 to -1, the ft will equals to -1, and from -1 to 1, the ft equals to 1, and from the boundary 1 to 2, the ft will equals to -1, and from 2 onwards, the ft will be 0. So for the graph, we will have a graph like this. So from t less than -2, the ft will be 0. And from -2 to -1, the ft will be -1. So from -1 to 1, the ft will be 1. And from 1 to 2, the ft will be -1. And from 2 onwards, the ft will be 0. So to solve the Fourier transform, the general solution would be the same as before, that is f omega f bracket j omega is the integral of -infinity to infinity ft exponential -j omega t dt. So we have to identify each ft and boundary for the for for the for the for each ft. So from minus infinity to -2, the ft is equals to 0, so that all the integration would be the 0. And for -2 to -1, it's -1, and so the integral would be minus exponential minus j omega t dt, and from -1 to 1, it would be like exponential -j omega t dt, and from 1 to 2, ft is equals to -1, so the integral would be like negative exponential minus j omega t dt, and from 2 to infinity, the ft is equals to 0, so that all the integral would be 0, so that we would only left three things to solve it. So after we have this line, we can solve the integral, and we will get a line like this. From here, we can substitute in the value into the t, and we will get a line like this, which is exponential j omega over jw minus exponential 2j omega over j omega minus exponential negative j omega over j omega plus exponential j omega over j omega plus exponential negative 2j omega over j omega minus exponential negative j omega over j omega. So we can simplify the for the like terms, and we will get a line like this. So from here, we will know that sine x is equals to exponential jx minus exponential minus jx over 2j. So we will have add a 2 here and outside here, so, and from here to here, so that we will have 4 sine omega over omega minus 2 sine 2 omega over omega. So Also we will have to note that sine c x equals to sine x over x. So we will have add the two here and outside here so that we can have the sine omega. So the final answer for this would be 4 sine c omega minus 4 sine c 2 omega. So for the Matlab of this, it would be like as shown. So symbol W, this is to declare the omega for the double, and for the omega we have set the range from negative 3 pi to 3 pi. The pi over 360 is to stabilize the graph so that the graph will be smooth, and the function will be 4 times sine c omega minus 4 times sine c bracket 2 omega. To find the amplitude so amplitude of the graph, the coding will have like ABSF. So after plotting the graph, we will get the graph like we, so after plotting the graph, we will have a graph like this. So for the this graph is for the amplitude versus frequency. For the phase, the coding will go like this, the angle bracket f. So after plotting the graph, we will get a graph for the phase plot is like this. So that's all for the assignment 1, and thank you for listening.